following Chalk Talk is brought to you by Isolite, the emergency lighting experts. Stay educated, my friends.
Thank you for joining us. It's late October Chalk Talk. I'm Greg Keel, along with our host today, Tom Deutsch. And as you can see, we're going to be focusing our Chalk Talk today on inverters. And I think it's appropriate doing this in the Halloween spirit. Our whole motto here at Isolite is we never want you left out in the dark. And Tom's going to talk about our number one solution for that, inverters. It's become a huge part of our business over the last several years, and we continue to see growth and opportunities in this space. And we want to continue to lead the way, being the experts on inverters. So with that, I'm going to hand it over to Tom Deutsch. Tom, take it away.
Thanks, Greg. Let's talk about inverters. This is a topic that we've certainly covered in the past, different, Inverter 101 type courses. But today I wanted to sort of take a different angle on things and talk a little bit more about why we're seeing so many inverters. Why are inverters, the thing that they are? Why are they essentially taking over the entire industry? So, as always, we'll do this in three parts. First, I'm going to go over a little bit of background, start out with a little bit of, Isolite's origin story, then roll into some of, the basics of inverters. Again, we've done that 101 course many times, so it's just one slide that we're doing on how these things work. And then I also want to take a slide and go over some of the complexities. So, we know why inverters, but I want to sort of dive into why not inverters. Not that there's any reason not to do an inverter, but maybe why some people aren't doing inverters right now. And then I want to do some comparisons. So let's compare inverters to generators, to unitary lights, and to emergency drivers. So pretty much anything that competes with an inverter. And then finally, we'll just go over some of the resources we have available for you guys. So for anyone not familiar with our story, we started out in 1984 with just one product. It was the self-luminous exit sign. These tritium gas exit signs were literally the only thing we did for a little bit. But eventually we did start expanding our product offering to LED products in 1998. And then since 2010, we've expanded our product offering to include literally every facet of life safety. And one of the first steps in that in 2011 was to establish our inverter program. We were actually the first to offer pure sine wave inverters. Nowadays, that is the standard. Almost every inverter you'll see throughout the industry is pure sine wave. And, very proud to say that we sort of kicked that off. But since then, since we launched our inverter program, since we started making these things, the amount of demand for them has increased steadily throughout the years. And I would say within even the last couple of years, things have really, really boomed. So there is a huge demand for inverters to the point where we are, almost an inverter company nowadays. It's half of what we do. We've dedicated so much time and resources to getting better at it, to continuing to stay the best at it, to the point where, we've had to reshuffle our factory multiple times. We've had to reorganize things to give more space to the inverters. Even right now, we're going through an expansion in our warehouse, to make sure that the inverters have plenty of space, and also to make sure we have plenty of space to continue doing the other stuff. So no less attention is being paid to the other stuff. However, the inverter part of our business has grown, rapidly. So I think the question here is why, and that's why I wanted to do this presentation, is to discuss, why are we seeing this happening? I'm sure we're not the only ones. They are absolutely taking over the industry, and I want to sort of dig into why that's happening. So for us, for why we are seeing the boom, I think one big part of it is that we do it very well, and we do it in a way that will be applicable to any sort of building type or any sort of job type. So if you want to, just power one or a few fixtures, say you just have a really small retrofit job, or just a little restaurant or something, you want to go with an E3U at that really, micro inverter size range. Our E3U is a really great product. It's packed with a ton of different features, considering how small it is. The E3 Mini is the same thing. This is a mini inverter. This is going to handle, a room or a floor of a building, and packed with features as well. It has, dimming capabilities. It has zones of ELCD built in. So also, a superstar product for us. The main thing that we do are these E3 Max. That's our biggest seller. And an E3 Mac is awesome because any building type, especially larger buildings, an E3 Mac is going to be a really awesome solution for it. We have a ton of different options you can get in the E3 Mac, and then the E3 Max is the same thing. It's just larger and covers less space on the floor, so you can pack it into any tight, crammed electrical closet. One singular point of maintenance. And then why us specifically? Why are we doing so well with inverters? Well, I don't think it's just that we were the first to market and that we've kept our foot on the pedal and continued to scale up and to really figure out what everyone wants with these things and to engineer the right products. I think that's one part of it. I think the other part of it is our support system. So we spend a lot of effort on both the front end and the back end supporting you guys on inverter sales. So anything that's needed to quote an inverter, we have a dedicated team, me, Jason, the Daves, Greg, and Matt. We spend a lot of time making sure that you guys get the answers you need for inverters, to make sure you're specifying the right inverter for a job. And then, on the back end as well, after you get this inverter, we're going to continue to make sure that inverter is in a good situation, that you guys have all the support you need if anything goes wrong. Things don't tend to go wrong very often, but every time they do, we're right on it. So I think that's sort of what gives us an edge. That's why Isolite inverters. And now that allows me to move on to, in general, why inverters. And the first step in why inverters is to understand what they do. So an inverter is just a device that connects between the power grid of a building and the utility panel. And when power is present, it's just going to pass AC directly through itself to whatever load you put on it, whatever emergency circuit you put on it. And at the same time, it's charging up its internal batteries. Then when power is lost, it's going to switch to inverter mode, and those batteries are going to become your power source. It's going to power the same luminaires that you were, passing through in the exact same way. You're not going to see a difference. You may see, a millisecond blip in power. That's the only difference. It'll run for 90 minutes or longer, which is what you need for your life safety path of egress. And that's it. Nothing too crazy, but there are a couple of little complexities. I think these are sort of the things, if you were to ask, why not inverters? For some people, I think maybe this stuff has something to do with it. So I think the most complex thing about an inverter is probably these ELCD devices. So just to make these seem super simple, I know a lot of you probably do understand this, but the way these things work is that every zone needs one. Not every circuit and not every fixture. So not every light has an ELCD with it. Not every, one circuit or one breaker coming off the inverter has an ELCD with it, but every zone. And the easiest way to think of a zone is just, a room or essentially a switch leg. So anywhere you have one zone of switching. In other words, if you look on the wall and you have 3 switches on the wall and those control the lights in a room, and you want all of those to be on emergency circuits, well then you would need 3 ELCDs for that. If just one of those switches is going to have enough lights on it to power that room, you'll just need 1 ELCD along with that switch. And it's not just switches, it's all sorts of all sorts of different devices. Any way that you can switch electricity in a building, whether it's more complex controls or anything like that, an ELCD can still override it. It's any sort of switching control. There's 2 types. The 1008 device, you'll see this pretty much wherever you don't have 0 to 10 volt dimming. So whenever you have 2-wire dimming or anything super complicated, you're going to want a 1008 device. These are a little bit larger, a little bit more expensive, and pretty much everywhere else you'll see 924 devices. These are small, basically the size of a switch. They fit in there right next to a switch, and anywhere else, if you don't need dimming or if you have 0 to 10 volt dimming, you can use one of these things. And that is where it gets slightly more complicated, is just with dimming, you do just have to run an extra wire for the dimming, but that's about it. And then maybe one of the other complexities would be, if you're curious about what the circuit design actually looks like with the inverters, because it's a little bit different than battery packs or unitary emergency lights. Well, there's just your utility panel. There's one breaker coming off of that panel feeding the inverter. That feed is going to power the pass-through, and it's also going to power the charging of the batteries, like I mentioned in the last slide. And then that inverter is going to have breakers on it, which feed to your emergency circuits, which then, are going to go to split up into zones, and you'll have your ELCD powering, next to your switch powering your load. And the way that's typically going to work is those emergency circuits are going to be taking every nth fixture, every second, every third fixture in a line, or every one fixture per room, every two fixtures per room, and that's going to be on your emergency circuit. If you have a 924 device, it's going to be a separate circuit than the lights around it, but you're never going to know that because it's all going to operate essentially in the same way. You turn on your lights, everything comes on, you turn off your lights, everything goes off. So just to reiterate, these devices allow you to override a switch control. They're not necessarily required for an inverter. You could have lights that always stay on or always off until an emergency. But in order to have a building that looks like and acts like it doesn't have emergency lighting during normal operation and then does when you need it, that's when you need these ELCD devices. Now, there are other solutions to emergency lighting. There's these regular unitary emergency lights, which, commonly called bug eyes, which we're all very familiar with. There's battery packs, sort of the original inverter. And then there's generators, which work very similarly to an inverter. And I want to sort of take a second right after this to compare all of those solutions to each other and sort of see how they do compare. But real quick first, I want to directly answer the question of why inverters. So primarily, the upfront cost is lower. You can compare it to literally any of the other solutions, and most of the time, if not all of the time, depending on if you got the right inverter or not, your upfront cost is going to be lower. It costs less to specify and install an inverter because you are buying in bulk. All of your battery storage is all in one place. All of your inverting is happening in one place. You're buying in bulk, and so you're getting a better deal. Additionally, operational costs are going to be lower. So there's two types of ongoing costs associated with any emergency lighting system. That is going to be monthly and yearly testing, and then also battery replacement, because batteries are consumable objects, so they're not going to last forever. No matter what sort of battery you have, no matter what sort of device you have, eventually you're going to have to replace those batteries. So inverters make replacing those batteries way easier because you're not going all throughout a building. You're doing it all in one place. They're larger batteries, so everything can just sort of happen all in one place at once, which is going to be a lot cheaper when it comes to hiring someone to do that work. And also, again, you're still buying in bulk with those batteries. The testing's a lot easier as well because, you don't have to run around and do, what we call a monthly red dot scavenger hunt. In other words, looking at hopefully SD fixtures to figure out if they have a red or a green LED, and then having to jot that down. The code states you have to, keep record of if your pass fail. The inverter thankfully does that for you, so it'll keep record and it'll, self-test, and it's all in one place should anything ever go wrong. One of the other huge parts of inverters is they help you avoid wall acne, so there's not stuff all over your walls and ceilings in a building. This helps boost the aesthetics a lot. They're also more likely to be code compliant because, let's be honest here, the amount of work required to maintain, code compliance with some of these smaller batteries everywhere types of solutions, that amount of work isn't something that a lot of building owners are going to do. It's just too much money and it's just too much time. So unfortunately, what you end up seeing is a lot of times there just isn't compliance. They're just not testing these things. They're not having a path of egress. And, we like the things that we have here for life safety to actually perform and be a life safety system. So when you go with an inverter, it's highly likely that you're actually going to have a legitimate path of egress through your building. And then also the best thing about inverters, they are completely universally compatible. They spit out AC the same way the utility company spits out AC. So any fixture that you could possibly throw on a normal circuit, you can throw on an emergency circuit. You don't have to worry about if those fixtures are going to be compatible or not. But real quick, let's just dive into the individual comparisons. So, if we're going to put an inverter up against a generator, I would say, first of all, credit to the generators. I think they are a good solution to emergency lighting, definitely depending on the situation. But inverters, they're a little more efficient. They're definitely optimized for emergency lighting, for your 90-minute, 2-hour, 3-hour runtime, whereas generators, maybe you're meant to back up for a whole day, a couple of days, and there's different things that come along with that, and that could be considered a pro towards generators because they do a little bit more. But inverters, you can still do motor loads, you can still do all sorts of other fun things with them. I just think if we're in the realm of emergency lighting, something that's specifically designed and optimized for emergency lighting would probably have the edge. And then the big thing about inverters compared to generators is that there's no engine. Large engines that require maintenance, they sit outside. A lot more can happen when you are outside in an unconditioned space. They're loud, they can be smelly, they can have, really long transfer times that might not even work for emergency lighting. So if you have a big generator, they take time to spool up. And if it's longer than 10 seconds, which a lot of times with the real large ones, it is, you're not going to be able to use a generator with your life safety system. So, and the only thing, if I wanted to really give it to generators would be capacity. These things can get extremely large and you could run massive systems off of generators. Inverters are also getting larger, all the way up to 33 kVA for us, and that's enough to run a pretty dang large building. As for emergency lights, I also think that these are a good, maybe not great, but a good, solid, answer to an emergency lighting system. So inverters, they are going to tend to have cost on them, although I'll admit that emergency lights are decently competitive with the upfront cost. Inverters, the testing and maintenance is going to be in, two different worlds of difference. The inverter is going to be 100 times easier to test and maintain than your emergency lights. And then the aesthetics are going to be 1,000 times better as well. The emergency lights, the unitary ones that, create wall acne and kind of wreck the aesthetics. If you talk to a lot of architects, not always ideal to have those emergency lights in there. But emergency lights, they do have one thing on inverters, which is they are the single simplest way you could possibly do emergency lighting. You just hook them up to any power source that is constantly hot, and they just work as long as the path of egress has been designed properly and everything. But regardless, they are incredibly simple, so you have to give them that. Battery packs. So inverters are going to have cost, installation for sure. Potentially dozens of times, dozens of less hours of time for inverters compared to in battery packs. The testing is going to be, just fundamentally way easier. It's going to be jam-packed with features. Battery packs tend to have 1 to 0, special features on them in terms of options and what you can do with them. And then the real knock on battery packs is compatibility. So they are compatible with almost nothing. So the voltages have to match up. The wattages have to match up. If you do get one that can power the right amount of wattage, it's probably going to be underpowered if you have a larger light. So they can't really run larger lights. They can't really run pendants because you need to crack open these devices and get to the DC side of things. So that's not really going to work. Troughers, they're pretty decent at, that's sort of what they were designed for. But once you start going outside of that realm, they tend to not really be compatible with anything. So battery packs, dare I say, crazy take. I would say no upside in 2025 for battery packs. Might as well go at least with in mini inverters. So here I just wanted to sort of break down the difference between a battery pack, for example, one we sell, the EMP, and a micro inverter that we sell, the E3U. Pretty similar. You're going to, for example, be able to run one fixture on these, but The difference is with the battery pack, you need to reach into that DC side of the circuit. You have to have the voltages match up because now remember, we're in DC land and things get a little more particular in DC land. AC is AC, but DC, there's all sorts of different voltages. You have to worry about voltage drop off, and there's just a bunch of different considerations. You don't have to worry about going over wattage because if you have a battery pack that's spitting out too much power, it's going directly to DC, so it's going to just blow those LEDs up. Also, they tend to have less power, won't last long. Compared to an E3U, which is already a little beefier in size, the smaller one is 36 watts. And the larger one's 100 watts, so you can put multiple things onto it if you want. They're easier to specify, easier to install, and certainly easier to maintain. So sort of an opinion piece on this slide. I really, really like the E3U over, our battery packs or any battery packs. Well, that's about it. I had a lot of fun talking about this. If you'd like to learn some more, we have several AIA courses available to you guys. Namely, we have a couple on inverters, some on those ELCD devices I mentioned, and one on cost comparison. So if you want to, see me back up some of the numbers or some of the examples where I mention that it's going to be cheaper to go with an inverter, I do back that all up in a pretty extensive example in that cost comparison AIA course. Also want to mention there's a brand new AIA course on batteries. Please feel free to schedule that one. I'd love to get that one as well. We have a ton of helpful documents related to inverters and all of the different solutions loaded up on our website under helpful documents in the resource center. And also want to mention we're here for design help. So anything on the front end, specifically I can help with in terms of making sure we're specifying the right inverter. So as always, there will be a follow-up email with a link to this as well as the PDF. Well, thanks guys. I've been Tom Deutsch, and together with Evan Ackman, Greg Keel, and Matt Bird, we are here for you. Please reach out if you need anything at all.